Welcome everyone to this afternoon deep dive session called Refactoring to a System of Systems. My name is Oliver Drootboom. You might have heard a different name before. I'm the living proof that calling a get method is not always side effect free. Try get married and then you end up with this. Joking aside, still the same guy, working for Pivotal in the Spring engineering team, responsible for Spring data projects, and for a lot of things that are kind of at the boundary of framework and architecture, where there's some kind of tension because usually you don't want to avoid some technology basically interfering with your architectural decisions. You want to have your code basically free of technical frameworks. But at the same time, it's nice if a particular technology actually supports different architectural decisions, and that's sort of what this talk is going to be about, which is basically analyzing, like, given you have a system that's been under monolithic development for quite some time, and you try to actually break that apart, what are the fallacies here? And the talk that session here is basically a summary of things that we've seen or that I've seen in customer projects that try to do that quite a bit, and things that I've seen gone wrong and things that I've seen working, and it's kind of like a bit of a structured write-up of exactly that, right? And it's all about, I'm not going to tell you, okay, this is microservices and that's the way you build them, and then yay, success. Or this is a monolith, stay with that, and yay, success. It's more of a like, we're going to have a look at alternatives, implementation alternatives, typical implementation patterns, especially for the monolithic implementation. Don't feel ashamed if you feel like one of the examples that I have is actually, my application looks sort of that. That's just fine. And we're going to just have a look at, okay, what are the consequences? What are the effects of the way that we were doing things? And what are the effects of maybe things we want to do? And are they actually, or do they bring us nearer to the actual goal we have with our restructuring of the application? Or are there alternatives, and what are the trade-offs for those alternatives? So what we're going to do is we start with a pretty prototypical monolithic implementation of an e-commerce application, and I've put in some stereotypes in here, so some patterns that we see in Spring applications, but that are probably, even if you're on a classical Java or Jakarta EE application, they should be pretty similar actually. And what I want to focus on for that is the interaction patterns between bounded contexts, because that's going to basically hunt us down for the entire session here. So what means do we have to implement bounded contexts, and how do they interact? How do they typically interact? Again, I'm not saying that has to be the case for, let's say, your particular application, but yeah, it's the stuff that we usually see in the field, right? Once we've done that and basically found out what's good or what's bad about it, we take the next step and basically assume that team developing that application went to one of the conferences these days and learns that like everything needs to be microservices these days, and starts to split up that system. The thing that the implementation that I've have prepared here is not actually split up in a bad way in terms of like where the boundaries are, but we're going to see what keeping the same interaction patterns around will basically bring to the application, and what that will actually, or what problems that will actually bring, right? Right. So with like then our knees deep in the mud of problems of, let's say, a distributed monolith, basically that's. Basically getting ahead of myself, but having seen that, we're basically making a step back and basically try to think of, okay, what can we change in the monolith to improve its structure, to maybe change the interaction patterns in the monolith, and maybe that's actually enough to bring us to our goal. So we will quite a lot talk about what do we actually want to achieve, like what's the goal of the separation, right? So the question is, can we build a better monolith in the first place? And there's not really rocket science in there. I'm not telling any secrets. It's just, okay, maybe we think of certain things in a different way, and then actually that has an effect of the way we build here. That's also the part of the session that's going to become quite a bit more technical. I have a couple of, I'm going to get to the sample code in a bit, but I have a couple of like prototypes that we're working on in, let's say, the Spring team, and like with some interested party around it, that actually help you improving that monolithic structure, because there's a lot of framework support for the microservices world, up to the fact that I talk to people that tell me we build microservice because there is Spring Cloud, which is not a good reason to actually build microservices, right? So, and we want to make sure that, like, no matter what architecture you're actually deciding for, there should be good support in terms of the frameworks, where support means it's not getting in the way in the first place, right? The framework, or it can actually help you do the right things, or help you do the shape things in a nice way. All right, so if we have that, then we can basically talk again about, do we still need to basically split this thing up? And if we do, our system becomes a system of systems. I like that term much better than microservices, because it's not focused on some kind of size and of any kind. And we're going to have a look like what these new interaction patterns of the monolith actually look like in that distributed in that new distributed world, that in how far that actually looks different than the original microlith implementation. And then we're going to discuss the trade-offs between two ways of actually integrating those distributed systems again. One is using messaging, and one is using REST. I was told there's a break to be scheduled in between of around about half an hour. Not sure whether, we want to like all get out of the room and get back in again. Depending on how things go, we might just like it might just be okay for you to sneak out to grab something to drink, and I just carry on, and you might miss a tiny bit, but let's see how we proceed here. There's sample code for this. I've built for all of the alternatives. There's a Maven module basically within that repository. I didn't actually update. It's odrotboom/SCOS. So if you Google for that, if you Google for the title and title of the talk and GitHub, then you find it. I'll fix the slides later on. The slides are also available already on SpeakerDeck. It's a slightly different version of than what you basically get to see here. I took the time that for all the trade-off bullet points that you're going to see in a bit, to basically note or write out the things that I'm basically telling you here, because usually the slides you present are not a good thing to look at afterwards, because they just lack any kind of context and whatnot. All right. So what kind of domain am I going to talk about? And that's actually the first thing that I want you to basically take with you through the entire talk. I'm talking about or I'm going to use an e-commerce domain as the example project, which means that all the considerations, all the evaluations of choices that we're going to do are basically applicable to any kind of client-server system. If you're building a high-performance trading application for a bank, or if you're building a second Netflix, you might come to completely different results of your evaluation, right? So all that stuff is highly depending on what kind of system you're building. So I'm not trying to preach you some kind of universal truth here. That's the important thing I try to get at. All right, so what's the domain? We have an e-commerce system that has a catalog containing products that have prices attached to them and some kind of product details here. There's orders you can basically place. Orders contain line items that, of course, refer to the products by some means, and we're going to have a discussion what that kind of reference actually can look like. And we have an inventory that keeps track of the amount of products that we actually have in our inventory, is what I was told recently, inventory, that basically keeps track of the amount of products that we have. I want to concentrate on two major use cases that that involve that interaction between these bounded contexts, and I'm going to get back to the two of them as I see fit for the particular part of the talk. One is that when we add a new product to the catalog, we want to initialize the stock. So the part of the system that deals with the stock will have to basically register an amount of 0 products for that new product, right? Because the reason that thing is interesting is the inventory needs to has to have a reference to the product. And if there's a new product and we actually need to notify the inventory by some means, that sort of creates a cyclic dependency between the two, and we're going to see how we can actually resolve that. The other use case is the probably obvious one, that once we complete an order, we actually have to basically update the inventory. Right? So let's say I bought 5 TVs, then ideally the stock at some point in time has 5 TVs less in its stock already. All right. So what does the monolith look like, and what do typical monolithic implementations of that actually look like? So what you usually have is, or something you can actually can find in a lot of those implementations, is some kind of arrangement of teams usually try to basically map those logical bounded contexts to some kind of artifacts in their implementation. That could be packages, that could be individual Maven modules, what have you, right? And then you usually in Spring Framework projects, there's some kind of database involved. There's if it's a relational database, then there's usually JPA. That's what I chose here. And there's some kind of modeling of aggregates going on. So there's the product aggregate, and there is an order with line items in, let's say, the other package or other artifact. And you can already raise the question, okay, what is that dependency between the line item and the product going to look like? Because if you're using, or if you have used any kind of reverse engineering tool for, here's my database, please generate me some entities, then there actually might be many-to-one relationship between the line items and the product. So you actually have a reference to the type product in the line items, which is kind of questionable, I'd argue. And that's kind of the first thing that I would want you to look at if you face a similar scenario, because that actually means that the order is referencing the product object, which in this case has prices attached, which causes in turn that once you change the price of the product, this sort of reflects into the order, no matter whether the order is already completed or what have you, right? So these aggregate relationships across bounded context is kind of an issue in most cases. So I'd like you to revisit that. The same applies to the inventory item, where it's probably not that problematic, because on the inventory item side of things, we only need the reference to the ID. So it's really literally an identity reference that we just care about, right? In the order to catalog relationship, there's some information that's relevant to the order, but if you think about it, the way that it actually probably should be modeled is that at the point in time when you place the order, when you add the product to the order, you'd want to copy the price over, because that only gives you the stability of the price, right? Change in the orders in the product's price doesn't or must not reflect into like any existing order. There's like things like if you ever experienced that on Amazon. Sometimes if you pre-order stuff, I buy a lot of vinyl on Amazon, and then you can basically pre-order a release of a new record, and when it actually comes out, then oftentimes the price is lower than when you originally bought it or reserved it, and then Amazon basically just charges you the lower price. So there's different strategies how you can actually deal with price changes, but by no means you'd want to actually see a price increase reflecting into your actual order. And although you talk about, let's say, this is the order, it has a line item and that has a price, because that's sort of related to the product, and the product has a price, and both things are called price, but they're different things, right? There's literally, that's a pretty good example of like bounded context, different bounded context, talking about the same thing, a product price, but actually meaning different things of different life cycles and whatnot. All right, so what does the interaction on an order completion actually look like? Usually it's a Spring Bean reference. So let's say we have like components of some kind within those bounded contexts. This is like classes annotated with add component and then wired into, let's say, some client code, and that client code invoking that code. There we are. We're already done here, or we're already here. That method could, I mean, that's very stereotypical implementation of such code. Is that big enough? That should be updates available. I don't care. So the thing I want to get at is, in this case here, is like, okay, that's a transactional component. So we have some business logic here. There's an order that basically implements that exact use case, saying we complete the order. Some non-null assertions, we change the status of the order, and then we invoke the stock, basically. So it's this thing here. So there's an active invocation of the inventory to update the stock. Why is that problematic? I mean, first of all, we're sort of introducing a cyclic dependency between the two, right? So the inventory, the stock, where is it? Where is my cursor? Here it is. So you see the inventory has to know about the order type, and the order basically has to know about the inventory. So there's a bidirectional relationship between the two, which is kind of problematic in the first place. And if I had structured that project as different Maven modules, that could have helped me to prevent that in the first place, right? Because there's no way to have cyclic relationships between compilation units here. The other thing is that in terms of if we want to, let's say, extend the system and we want to add a new module that maybe actually adds up some kind of reward points for every order. So let's say for every order you get, for every like $100 you get like 10 reward points or whatnot. Then you can have an entire team implementing that. You could separate the work. You could define APIs. You could just have another package, another Maven module to actually let the team build that. However, at some point, the team managing that bounded context will have to go to this piece of code and actually write or add this kind of line saying pseudocode rewards dot update rewards, what have you. Right? So there is some kind of gravity actually coming from this kind of code, and that's coming from the fact that we have some kind of a business case or a point in time in the business logic that's kind of important to the business, right? So, and a lot of logic is tied to that. You'd want to send out an email for a successfully completed order, probably just as a receipt or something like that. What's pretty nice about this thing in the first place is you've seen that transactional annotation here that has or basically causes the entire method invocation to roll back in case anything goes wrong. So let's say we could save the order, but while updating the inventory, something went wrong, the entire process is being rolled back. That's kind of nice, and that's a nice example of technology making something very easy, right? So that's I mean, you have the same thing in Jakarta E, but just there's an annotation you put here, you get transactional semantics, you get consistency. That's very convenient and nice. But at the same time, that kind of structure and that kind of interaction pattern, that gravity that comes from that method, will then continue to actually enclose more and more business logic being executed within that method. If I just add the rewards program here, that's going to be added, and if there's a tiny bug, throw in an exception in the rewards system, that will roll back the entire order completion process, which is something we wonder. Is that something that we really want, right? Shouldn't there be like, okay, we want to complete the order first and then have like secondary functionality being executed here, right? So it's kind of like, it's very easy to grow these transaction boundaries quite a bit up to a very unhealthy point, and it's so easy because it's just so very convenient to add this annotation here and have things work. But it might not be the best thing to do, right? Just to keep that in mind in terms of like, okay, a nice framework feature might create incentives to do something that turns out to be a bad idea in the long run, or if systems grow. Especially, I mean, that kind of God class or high gravity methods is something that we see in evolved monoliths quite a bit, right? So because where do you add that functionality? Yeah, you just put it there. Something else? Should we discuss the stuff above? As a side note, it's not really entirely important to the subject at hand, but we very often see code like that. Once you've done trying to decipher this, that's actually the point here. It's not that I want to distract you with like, oh, just to have this to understand this. No, that's actually the point that I'm trying to make. This stuff is hard to decipher, and it's basically just the functionality. The method name is kind of suggestive here. It says, okay, add a product in the given amount to the given order. And by the way, the line items are actually working within that order. You add a new line item if none has been present for that order, and if there's one, then you just like increase the amount for that one. And that's something we see that's very typical to let's say projects that haven't really grasped domain-driven design yet, which is kind of like they treat the domain classes, the entity classes, as dumb data containers, right? So that code has to know a lot of the internals of that order. It pulls out the line items. It knows the way the line items are held actually internally and streams about them. There's a bit of you could improve that slightly by moving to a newer version of Java with a couple of more methods on optional, but it's very like procedural code on data, right? So, and that's something that you can basically improve. You oftentimes improve by moving that code or hiding that code within the actual aggregate. That's something I'm going to come back later as well. So we usually recommend to try to make the aggregates a bit smarter and a bit nicer to use. All right, let's see if I actually have mentioned everything. So what I think is a good idea, and I actually have a talk about that on Thursday morning, is that you try to find some means to actually reflect the bounded context in your code base, right? It's kind of like a pattern language that you want to apply here. A good start has been to use packages for that. As I said, if you want to know more about that, there's a talk on Thursday morning about monoliths. Basically, I'm getting ahead of myself again. Something that's really nice here, and that's often overlooked, is that the intercontext interaction is not actually leaving the process. Which means it's fast, right? Much faster than any kind of marshalling, reaching out over a network, or whatever. Again, unmarshalling, executing some logic, and then do the same backwards for the response. And there's exactly two outcomes that you have to deal with. Either the call is successful, or it throws an exception. So that's kind of the two things that you have to deal with here. So it's very, very easy to consider or very easy error scenarios, really. I mean, you still have to find out what to do in these cases, but it's only two. That's kind of helpful. The other thing that's often under the radar, basically, for this, it's a pretty neat and effective way to implement exactly once delivery to the other party, right? Very hard or close to impossible to implement in any other way, really. That's kind of nice. Yeah, that's something I discussed before. So there is some value in being able to just say inventory or update stock for rewards dot update rewards for yada yada yada, because it just reads nice, right? So you can just like look at the method and you can see every step that's basically taken here. And in case anyone is interested to find out what's happening when an order is completed, just need to go to that method. That's definitely a plus. On the other side, that's a domain class reference. On the other side, that direct reference to a product instance from the line items, I didn't actually show you that, but I think you can imagine that, is kind of problematic because you basically tie different kinds of life cycles of data together. And usually, if there's a bounded context boundary in between the two, then there are different life cycles, and you much rather just keep the reference, like in terms of an ID, and copy the data over, and then in case you need up-to-date data, just resolve that other object again. Yeah, I mean, that's like the broad point here that I'm like sort of not really criticizing, but okay, that's an effect that you have to be aware of. So the active invocation, which also means that there is, just if you think about it from the point of view that like who has to have knowledge about what, right? The order management team has to have the knowledge that there is some inventory update to be done while the order is completed. It can't actually focus only on completing the order, but it has to know about all the secondary functionality that has to happen here. And that actually and usually grows over time, especially if you add more other modules, bounded context, what have you. That's what I mentioned as well. And yeah, that's it. On the positive side of things, what I find is also like undervalued in that kind of approach is that it's pretty easy to refactor that code. And what do I mean with that? I mean, of course, we've all seen that big ball of monolith where like trying to change something like and causes all hell to break loose. But from the simple just point of view of, okay, what do I need to do to change a method? I can just use my IDE of preference and then go use the rename method feature, and like the called code and all the calling code is updated at once, right? I can actually go ahead and change field names of customers, of products, what have you, and I can reflect those changes through the entire code base. That already gets more complicated if you split up the project into multiple compilation units, because the same feature then requires all of them to be, let's say, part of your refactoring step. But in general, we have that's kind of the counterintuitive part to it. We have some high coupling here, right? Because it's like type dependencies all the way. But we can actually make use of that, and that tighter coupling gives us the ability to refactor, right? Just because we know that first name here means first name there. I mean, we know, and the compiler knows. That's the more important thing here. So if you are in that situation, use that, right? So it's kind of a big plus here. What's also nice, because, I mean, it makes our developers' lives much easier, is that we have strong consistency. As I said, with the add transactional annotation, we can basically assume that all the code that we invoke, if that ever was supposed to throw an error or something, the entire thing is rolled back, right? It's undone. So we don't have to think about like what happens, like if in that problematic scenario, do we need to like have some kind of compensation going on or anything? That makes stuff really convenient, right? We can use database constraints that just then fire and say, okay, there's some value that must not be, let's say that scenario when there's like 5 TVs available and I order 3 and one of you orders 2 or not also 3, then one of our orders basically has to be rejected to some degree, right? Because we say, okay, 0 TVs is something that we can't go into the negative space with the amounts of TVs available, right? Pretty easy model to think about. On the other hand, that also makes, quite a bit things tricky because if one of the fundamental assumptions, I'm not yet going into the discussion about eventual consistency, but sending out that email about a completed order is not something that fits into that model nicely, right? Because we can't actually just like say inventory update, rewards program update, email, send email, because if that works and then the transaction rolls back, then we have sent out an email for something that hasn't really happened. So we actually need or we need to use that situation, or we have to wait for the transactional commit first and then have to execute some additional action anyway, even in that strongly consistent way. The other thing being, oftentimes it's not even that helpful to go that or take that easy route of saying, okay, we can never have a negative amount of products available. Why not? We could just, instead of like providing some bad customer experience, saying that, let's say, stick with the example. We have 5 TVs available. I'm ordering 3. Someone of you is ordering 3. Let's say I was a bit early, so you actually got your order rejected saying, oh, we don't have enough TVs in our stock. Why not just accept the order and basically trigger us going to our suppliers and, okay, we need more of these TVs. You don't actually have to do that in the basically bound to 0, right? You don't have to trigger that supplier trigger in turn when there's no TVs available, but you could just like go ahead and actually say, okay, oh, there's only 5 available, we better order some ourselves so that we have enough in stock, right? And then we can the thing I'm trying to get to is oftentimes it's that violation of a seemingly simple rule is something that you can use to your like business benefit and actually have it's beneficial to model that explicitly rather than just throwing that exception and rolling back everything in the world. Rather accept that problematic state and then have some kind of concept to actually deal with it. Because like throwing that exception and saying, okay, error, user, go away. Right, that's kind of the easy thing to do, but at some point you will have to think about the business implications of that anyway, and then oftentimes it's much better to actually explicitly model that missing state. A classical other example is airlines ticket bookings. We just discussed that last night. That the fact that it's kind of weird that it's even legal to sell things you don't have. The aspect being here that usually airlines sell more tickets than the plane that they send for that route will actually have, by just because of the mere hope that someone would not be able to make it, and then that other person could jump on. Anyway, order management becoming a central hub for new features. It's sort of the same thing that I've mentioned on the last slide. There's like this kind of team and organizational issue coming into this. You will never be able to integrate any kind of new feature into that order completion process without touching that very code, right? And that's something you might just want to avoid, not for technical reasons, but for like organizational reasons, meaning when can I go ahead and actually ship that feature or deploy it, right? Because you always have to at least ask, or you can, if there's some agreement that you can just change the code of the other team's realm. Fine. All right. So let's assume we have a team that sort of built this kind of system or these kinds of systems for, let's say, a couple of years, and then attends a couple of conferences and gets told microservices basically means bounded context define the deployment boundaries. So we have to have a dedicated system per bounded context, right? And that actually meaning that we sort of have to provide an API, right? Just as we provided that API before, we now have to provide a web-based API or something like that, and then go ahead and implement that other feature. So what does that basically our bounded context landscape then look like? That's the thing that's just been a logical kind of boundary, hopefully like put into packages or at least jars, even in a monolithic system, is now becoming a separate system. And the first issue already is that kind of identity relationship between the order's line item and the product still persists. So we now have to reference identity within another system. That's kind of like a tricky thing to have. Like before, we could even go ahead, and it's what we deemed like suboptimal. We could even reference the entire object in the first place. And I recommended to rather switch to referring to an ID in this case. But now that ID is not even living in my very same system. It's something like defined by a remote system, really. So we have to find some means to actually resolve that. And then we've got this kind of for the two use cases that are made up in the first place, right? Like the catalog adding a new product. There's got to be some invocation of some functionality in the inventory, and there's for the order being completed, there is that functionality to update the inventory has to be invoked as well. So what do people usually do? Okay, we build a new system. We build an API that's probably something related to REST, right? HTTP and JSON. So instead of calling that method, we just change that to basically issue an HTTP post, right? Because we're changing. That's how far we actually understood HTTP, right? There's some side effect to the invocation, so we have to use an HTTP post and to update the inventory and to initialize the stock. We do that, right? So what are the problems with that? First and foremost, you basically throw that simple local strong consistency thing is sort of gone, right? So there's no add transactional you can still have that add transactional on the method. However, if you just replace it by post for object and post for object, that's a method invocation in a different system. So there's no way to actually to have those interactions take part in the same transaction. Even worse, those external invocations are usually significantly slower than a local method invocation. And then they just interact with some other systems. And oftentimes, if you get to that kind of architecture, that system that you call might even have to call other systems to fulfill its purpose. Like once you've actually drank that kind of Kool-Aid, that's usually like systems calling systems calling systems. And that's taking time. Increases the time that the original transaction actually takes, which usually causes a bigger data source connection pool saturation, because the single connection is kept around or is kept busy for a longer time, just because we're waiting for that remote communication to actually go on, right? And so what we've basically done is that we've translated the interaction patterns of the monolith into a distributed system, and that creates a plethora of new problems, really. Right? So we have RPC-ish HTTP invocation. Well, that might not be a nice thing, but it's not necessarily problematic in the first place. But we sort of created a set of new problems, and that's something that I see a lot of teams ironically do, or that's usually a consequence of, oh, we're doing microservices now, right? And we're being told this is to make the business more agile and to ship more features and to focus on the business logic and whatnot. And what I see people do in the real world is that they start automating deployments using Docker and Kubernetes, and then adding more technology because they need to protect their remote invocations against the system not being available, the remote system not being available, the remote system being slow. So it's about timeouts and bulkheads and whatnot. And it's completely the opposite of thinking about business logic, right? It's basically staying busy with technical problems. Yeah, that's cool. We like to do that as developers. So I've listed, a couple of technologies here that I usually see in use. By no means am I saying that this is bad technology and that you shouldn't use it. The thing is that oftentimes we sort of create new architectural problems that we solve using technology that we wouldn't actually even have to solve, or there's a way to actually prevent the problem in the first place. And if I can do that, I'd always prefer that. So basically always prefer the simpler solution over something that is like involving a lot of tech stack here and tech stack there. And I'm not actually, that's why I listed Spring Cloud there. We're sort of guilty, quote unquote, of that as well, because that's what I mentioned before. Because there's so sophisticated support for all of this, it basically leads us to a way of thinking, okay, that's the way we have to build systems these days, right? And oftentimes that's just not the case, right? These tools come in handy if you actually really need to do that kind of remote, or have to execute that remote invocation. But that doesn't mean that you should basically base your system on a single system talking to 50 other systems, like while it's serving a user request. Which leads me to the other aspect, and that's actually the more important but less technical one. If you think about it, like microservices say, okay, we want to have this bounded context, and we want to have this deployed as that's the next step, and it's actually good. We can discuss those in parallel. It actually means that I should be able to talk to that system and get some answer from that system that gives some kind of business value. And that particular system, it should be able to answer that question on its own, because otherwise the system itself is not providing as much value as it actually could. And the reason here being, like, if you invoke, let's say you have a user request, let's say a mobile application coming to your system, and if you need to talk to 10 or 15 other processes, it just means that you've not really implemented bounded contexts, right? Because the context in itself is something that carries enough information, enough business process logic that it can actually have or have some meaningful value add to your process, to your project. We're going to get back to that in a second. One other thing that I've seen people are then often attempting is, okay, because that remote request is slow, let's reach out, let's use some asynchronicity in there, right? So have a thread pool going on, like, so that I can parallelize the REST requests. And okay, then of course we need that thing to scale, so we need to use reactive programming and whatnot, right? If there's a different way of architecting that, then I definitely prefer that to avoid the additional complexity. Accumulated latency, fine. So going on with the problems, because that's not everything here. So we've already identified we need to talk. We have this remote invocation going on. That means we have a network in between, and the other system could be down, the other system could be slow, which usually is the same as down. So there's a lot of we have to basically add a lot of means to control these issues, right? Like bulkheads and whatnot. More fundamentally, in the first place, then all of a sudden have to know who to talk to in the first place. So I need something like service discovery in the first place, which is something that in the monolithic way, as bad as it was, I didn't actually even have to have, because I was just auto-wiring a dependency and then just calling the thing, which is good and bad in the same time, but going to get into that on Thursday. What the consequence of that actually is that testing becomes much more complicated. So if I want to test some functionality of my system, and executing that functionality involves reaching out to other systems, then I actually need to have these other systems running, or I need to have at least stubs or mocks of these other systems running in the first place, right? And that complicates my testing efforts. I mean, if you think about it, what we're basically doing is we move the interaction between the bounded context up onto the integration level, right? So it's not in process anymore, it's across processes. And what could have been a unit test in my monolithic world, because I just need to, let's say, use Mockito to mock out the other part of the system, and then I can just like write a test that bootstraps fast, and that could be even a unit test. It might not even have to include, let's say, starting up the container. With that kind of style, we need to not only bootstrap our own application, we also need to bootstrap other applications that we then can trigger some functionality and let these systems check the interaction, right? And that kind of adds to that. These tests are running so slow. There's like many tests that we have to use more integration tests. We can't actually unit test anymore. Yeah, right. But that's what you basically asked for by just taking that step, right? Something that I will go into much more detail in my other talk on Thursday is that oftentimes we see a very strange way of people defining APIs, and I'm probably going to leave most of that to the talk on Thursday. But it's all in context with that other bullet point here that I've just added like right before the talk, and that is, I mean, in our case here, we've chosen context boundaries that were actually quite reasonable. They were context boundaries amongst bounded contexts, right? So we have the order system, we have the inventory system, and we have the catalog. So that's business basically factors, right? That we've chosen here. Very often I see teams that have a big ball of mud monolith, looking at their project and their code, and then having to find something they can extract from that. That's how these projects usually start, right? We want to externalize a part of the system so that we have some kind of prototype, and then we can learn from that. And and oftentimes the only structure that's still available in those big balls of monolith, big balls of mud, is layers, right? Because layers are technical, they don't have to do with the business, and they're pretty easy to basically consider and to actually not, or to have code written that actually adheres to the layering, right? That's quite reasonably or very easily to be done, and that's often the case why teams start trying to factor out layers of their application instead of like vertical slices, really. And that again then leads to the problem that I mentioned before, whereas to actually fulfill a user request, you now have to involve a network hop to another system, and it also leads to APIs that, let's say, oh, the data access layer, for example, that could probably be its own service, right? And then we can have like entities that, and we can have CRUD operations, and then we have like all our clients actually just interact with that API instead of talking through some data access layer with the database directly, right? Or the common, very common case I see is, oh, we have some kind of reference data service built somewhere, and that's just actually getting some. There's some clients and they're doing some HTTP interaction with the talk with that service, and that leads to those cruddy APIs that usually are easy to build in the first place, but as soon as you try to change things around them, things get problematic here, right? That's like another kind of common anti-pattern I basically see is that although we actually started with the idea of, oh, we build a system of systems so that we can evolve the individual systems on their own, right? So the focus was to not to initially build them quickly, but to basically be able to change them. But at the same time, when designing those APIs for those systems, we often just like, okay, what's the easiest way to generate an API quickly, right? And to get some kind of nice, colorful, fancy user interface to play with that API. Okay, there's probably some tool for that, but what we often tend to forget is that if we have a CRUD API, like on the HTTP level, then like imagine like when you have just a Java application. Let's get away from web APIs. If you have a Java application and let's say you have a repository layer in that application, where does the business logic live for that application? It lives in the client code of the repositories, right? So if you elevate that repository layer to the web, then that means that all your business logic is actually sort of implemented in the client, and it's not only there because it also has to be checked on the server side, because otherwise, I mean, why not just give that other system access to the database directly? And that logic has to be kept in sync, and that's kind of the issue then, because that basically multiplies the effort of every change that you want to make to the server API by the number of clients that you actually have to satisfy here, right? So change the way, let's say, credit card numbers. We want to add American Express to the list of supported credit card numbers, which means that the regex for that thing changes, and now we have a mobile client, and we have a website, and we have yet another mobile client, and some other systems talking to that API, and they all need to be updated. So what I'm trying to get to is that oftentimes a decision that's just like evaluated locally, how do we build these APIs, can optimize for local effort. So what do I need to do to create this thing initially? And by that, you could actually cost a lot of effort in the clients for every follow-up update, and it might be worth investing a bit more time, not using the fancy new tool that allows you to build an API quickly, but think it through, invest a bit more time, so that like down the road you actually it's much less likely that you break the other clients. But we're getting back to that in the other talks if you want. All right, so a couple of downsides, well, consequences. That's what I rather call them. There is, as I said, it's what I'm trying to get to is the giving you a picture of, okay, like we start this, and the issues that I've listed come, like the primary thing they come from is that we keep that interaction pattern around. So that direct invocation interaction pattern is causing these issues. So we have to find a way to get around them, both in the, let's say, I'd rather start to optimize with that problem in the monolithic approach, but there's also like ways to actually transfer that into into the distributed system. We have, what was it, 180, we have 75 minutes, 105, that means 20 minutes left. Okay, until the break. All right, so the monolith. So we've seen that there's a couple of downsides to that, let's say, naive approach of building microservices. And the question is, okay, what if we had started with a slightly different monolith, or modulith as I call it, what effect, I mean, would that restructuring of the monolith already improve the picture for that implementation, and how would that actually work or look like if we decided to externalize or talk about these, start splitting up the system later on. So the idea is that we still keep our ways to express bounded contexts around. So whether that's packages for you, whether that's jar files or Maven modules, I don't care that much. The fundamental difference now is that instead we just try to get rid of most of these direct invocations and rather make those business events explicit in our domain. So that basically means, okay, we produce the bounded contexts, produce events, and the other bounded contexts then can actually subscribe to these events by some means. And there's not, I really want to stay with the term events here. It's not because most people, when I say events, they hear messages. But what I'm trying to get to is there's a way to actually build those events in the first place, and or there's technological support in both the Spring world as well as the standards world to actually implement that kind of stuff. So we can then, with the inventory, subscribe to these events. What was it? Product added or order completed. And then those events will, by some means, we'll have a look at that, published to the inventory. And there is API that you can use to actually implement event listeners, in-process event listeners, and that inventory could then actually also produce an out-of-stock event. As I said, or I mentioned before, that use case where we basically have these concurring orders, and we sort of have to deal with the fact that we basically run out of TVs to be shipped. And that in turn then could be used by a potential new module that basically says, okay, the purchase system or the purchase part of the system, that's not even existing yet, but we can start producing the event and then later on implement that automation here. So how do these events work in Spring Framework? That's basically what I'm trying to get to you. So an event, where is my cursor? There it is. Hard to spot on that screen here. So events, the fundamental interface application event publisher is this one. So Spring Framework has a component that you can or exposes a component available for injection that you can use to publish events which are simple Java objects, basically. That looks like if we went to Order Manager, so what we'd have to do here, we would just create a private final application event publisher, and that's, instead of doing that, we just go ahead and say publisher dot publish event, and then we say what was it, order completed. I don't think in that module the completed of this, for example. So we create a new event that doesn't compile because that class, that Pojo class order completed, doesn't exist in the project. But that's fundamentally the way this works. The event publication by default is done synchronously. In other words, you're just interacting with some kind of framework event bus that then invokes all the listeners. We could have a let's say in another class, I'm just put it here for let's say event listener, and say public void on order completed event, and if that method is called, Spring Framework knows about that method. We're going to see that like without compile errors in a second, but that method is called synchronously. It's part of the same thread. In other words, it also keeps the same transactional semantics, which is kind of a neat thing to have, because it just means we're basically inverting the callee side, and we can by that avoid the reference to a component from the other bounded context, because that means we can actually get rid of that thing here, and by that resolve the cyclic dependency. Yay! That's kind of nice. There's a couple of things I don't like about that, which is that we now all of a sudden have to have framework dependency in our business code, right? That's kind of like application events publisher. That's in other words, for tests, I'd have to create an order manager with, let's say, a repository, fine. But like if I write a unit test, I'd have to provide a mock for that application event publisher. It's not something I'd really want to do. The other thing being, the event publication is, like in this case, implemented in a component. In this case, like conceptually, it's more of a service. In other words, there's some code that interacts with the aggregate, and then there's some code, the same code then or does that first, and then goes ahead and publishes the events. So, and as I said, we were like in DDD, one of the core basically mantras is basically to have the aggregate to be in control about like the business logic and the events being published. And there's something that we built into Spring Data, which is the ability to publish the events or accumulate events on your aggregate classes and have the repository interaction actually fire those events. So that's what I basically told you. The idea in Spring Data is that you can have annotations on your entity or aggregate root class, and we will inspect your aggregate root class for these annotations, and if they are present, we will like on save publish events that you like exposed through methods annotated with these annotations. You see that in a second. There's like, that's getting back to the tension that I mentioned before. I would really like to have framework support for that, but at the same time, I don't really want to tie my domain classes to your framework, right? That's the reason why there's two flavors. One is annotations, and the other one is just there's an abstract base class that you can extend to get that functionality. Right, and then you basically just like get these events published. It just looks like this. I mean, that's basically the variant where we don't have a problem with extending a certain base class. Just like abstract aggregate root of order in this case, and that one exposes a register event method, so that we can add the event to that to a list. We have the time. Abstract aggregate. So what it does, it just keeps a list around of those events. There is a register event method that just adds that thing to the list. There is a domain events method. That's the annotation. That's kind of the important bit, so that it will just return all the events that have occurred. And there is some method where you can just like add additional events, yada yada yada. And there's this after domain event publication annotation that's then used after the publication has happened. Then all of the events are cleared from that aggregate. And the effect of that is that you can now have order manager in the monolith, that the code can start to look like this. the service implementation, or its only purpose, and that's actually like getting close to the purpose it's supposed to have in the first place, is to define the transactional boundaries. So here's an add transactional, which means that's implicitly available as here as well. And that order complete method here then does all the heavy lifting. It changes the status of the aggregate, and it registers the events, right? There's a bit of like event copying going on, because I wanted to keep that class as immutable as possible, which is kind of a weird thing to say because it is either immutable or not. But yeah, so keep all the events you have and just add the one that we're adding here. Also see the method that I complained about before. That's now changed, or it's now moved to the order aggregate. So the order manager, it doesn't actually need any code in the service in this case anymore. We just need to load the order and then can say add product amount, and we'd be done with it. So it's kind of like trying to make the aggregate the centerpiece of the logic of that bounded context, right? And it's kind of basically providing a nicer API. Also see that the complete method here is package protected. In other words, there's no way that even if this was I think this is the monolithic code here. So there is no way for anyone outside that package here. They can see the order type because it's public, but no one can actually change the state of the order outside of that package, and that's why you'd have to call that order manager method. That thing creates the event, and the event gets published once you trigger the saving of the aggregate, right? So you invoke business logic that accumulates events, and once you decide, okay, this is the state I want to persist, then the events get published. Admittedly, I can totally see that if someone says, well, now I'm not really able to see what's going on anymore, right? There's not this nice, okay, step-by-step thing. See, inventory, update inventory, reward system, update rewards. That's not happening anymore, but that's the price we sort of pay for the increased isolation that we now have, that we don't have to refer to other components of other business bounded contexts, basically. Right. So. Sheesh. There we go. Seen that? And with that, I think we're going to let's do this. Let's do this this section still before the break. What is it? 180 again. 90. Nope. 75 means 105. Okay. 10 minutes left. Sorry about that. I just have the time left here, and there's no indication about break times or anything. Events and consistency. That's something that gets pretty interesting, because if you start using that mechanism, and by the way, the stuff that I've shown you until now is all available in released Spring Framework, Spring Data versions, what have you. Stuff that I'm going to show you now is in prototypical status, available on in repositories or in the Spring Framework repository. However, it's not part of the official of any official Spring Framework release or something like that yet. So how are these events processed in transactional, when you invoke the method, the transactional method? How does the event publication actually fit in there? So let's say we have this transactional method here. That's the green block basically, and we have code in there that gets executed, and then we have an event publisher publish. That means the event gets like just handed into that method call, and there's a so-called application event multicaster involved that then knows about the event listeners that we have like sort of scanned for at application startup time. And then we can, okay, yeah, that's the event that's being published, and we now know about all the event listener methods. We can filter by type and yada yada yada, and we can invoke those, right? And if once they're completed, the actual the method execution returns. So it's literally a synchronous indirect method call to all the event listener methods. They can be ordered so that you basically can define that event listener goes before the other one, although we'd recommend to not rely on a certain order here. But at the same time, or then usually the method actually commits. And then there's a second phase and a different kind of event listener that you can deploy, which is called transactional event listener. It's not the best name I think we could have found. Well, it's the best name we could have found, although I still think it's kind of like, it's not about the fact that the event listener itself is transactional, but the event listener is executed once a transaction is in a certain phase, and the phase that's triggered in by default is the commit. So you can basically write code that says, within that method can say, okay, application event publisher publish order completed, and then have a transactional event listener listening for that order completed event, and it will not get triggered until the transaction actually has committed. Which is kind of neat for exactly the use case we've seen before, or I told you about before, is sending out that email, right? So we want to make sure that all the stuff has actually worked, the order has been completed, the inventory has been updated, and only if that's already, that's written to disk and it's actually safe, we want to trigger these transactional event listeners, right? You can also tie these event listeners for, let's say, to a rollback or just to after completion, which basically means it gets fired either with commit or with on rollback. But the primary use case, I think, is tying listener invocation to transactional boundaries. That's been available for, not saying decades, but I think it's since 4.3 or 4.2, Spring Framework 4.3 or 4.2, that is. Yeah, right. And then we basically just exit the method. So the consistency boundary is basically where that blue bars go. So everything that's happening in there takes part in the very same transaction, and it means that everything rolls back. So we have a couple of error scenarios here, and we just want to have a look at how they basically affect the state of the system, like the consistent state of the system. So we could have a synchronous listener failing. The effect of that is that the entire transaction rolls back, and both the logic executed in the listener, or the changes of state in the listener and the changes of state in the actual business logic, they just consistently rolled back. That was basically the scenario that we had for the inventory update and the order completion. In other words, we can, let's say, if we reject the inventory update, let's say that we are out of TVs and we reject that through an exception, we can actually go ahead and break or roll back the entire business transaction if we want that. So the next step, and it's something I haven't actually talked about, is that these event listeners can also be asynchronous by just like annotating the method, the event listener method with at async. With that, you basically run in a separate thread. In other words, that's a thread that's not actually taking part in the actual transaction. In other words, you cannot even be sure that you see any kind of data changes that have happened until then, right? So it's kind of like if you pull out of that synchronous execution, you're basically on your own, and you usually then trigger or use another transaction to actually guard against like if you have multiple things you want to change in there. The other okay, the transactional service execution can fail. There could be a commit or a rollback or a constraint violation on order safe. That would also mean that the code executed by the event listeners will also be rolled back. That's fine, right? The interesting thing, and that's what stuff that we're currently working on, is the scenario where we have a transactional event listener and that is failing. So let's say we implement an event listener that's actually sending out emails, right? And it's trying to reach the SMTP server. The SMTP server is not available. And at that point in time, the system crashes. Then we have published the event, fine. We have sort of handled it in the transactional event listener, but now it's sort of gone, right? And that's kind of problematic. I mean, it's a rare case. For the case you can that the SMTP server is not available, you could build in some retry mechanism. You can say, okay, let's say when that event's coming in, I'm storing that I've received the event but not finished handling it yet. Then I try all my expensive business operation, and then I can go ahead and just retry that. But if you're not doing that and the system goes down, then you sort of lose the event, really, and that's probably something you would want to avoid. And after the break, I'm going to show you what we're building to try to work with that problem. See you back in, what is it, 30 minutes then? 3:15. Thank you very much so far. See you back in half an hour. The second 75 minutes, we basically left at the issue that we can run into with transactional event listeners. I have pulled up the implementation for that here. What I'm basically doing here is I'm listening to the bounded context itself is listening to the event it published itself. It's asynchronously invoking that, or getting that method invoked asynchronously, which means it's a different thread. The original method is returning, and we're just because we just want to send out that email, and as that might be rather slow. In this case, 1 second. We'd want to execute that asynchronously, right? And the issue being that while this code is basically executing and the system crashes, then the event is lost. So we've never really got that email sent out. And we sort of have to build our own kind of tracking mechanism of which event was published and which event was not. Some people then argue, okay, we might publish an event to an external broker or anything like a messaging system. Still, that requires some kind of interaction, because if I can't reach the broker, if I can't hand off the event properly in the first place, then we still have the same problem. So. What kind of ideas are we playing with these days? The idea is that because we're talking about transactions, so we are we start with the assumption that we have a transactional data store in place anyway, right? And we could we got the idea that we could register the event publications with that transactional store while you're actually using it anyway, and make use of it to actually remove the issue of losing events in the following way. So when, let's assume our application has these transactional event listeners, they are supposed to be triggered at transaction commit, and the framework knows about them. And it knows about them at the point in time when we actually publish, when we say application event publisher, publish event, either directly or through that Spring Data indirection from the aggregate. But what basically happens is that the event is handed, or like once the transaction commits, so technically there's a transaction synchronization registered that on commit then takes the list of transactional event listeners and invokes them one by one, like synchronously by default. So invoking the first one, waiting it till it completes, and then and so on. And what we can do is, at this point in time, we could actually because we know about the list of event listeners in the first place, we can write some sort of log where we say, okay, this transactional event listener has to be invoked with that event, this transactional event listener has to be invoked with that event, and then also equip the event listeners or wrap them with an, in this case, AOP aspect that will tick off that event log on successful invocation. So assuming our, let's say our first transactional event listener works, right? So it basically completes successfully. We can remove that entry from that transaction event log and just basically remove it. Then a second one starts and that fails, which means that entry stays in the event log. The next one stays as well. And the fourth one, let's say that completes again, and that means that thing is ticked off. That gives us the opportunity to then have some kind of recovering mechanism that either, like in a scheduled way, checks these publications and republishes these events to those event listeners in particular, or in case the application crashes, we can just like on Bootstrap, make sure the application has started, it checks the outstanding event publication log, and then invokes those methods again, right? Right. So that's basically the idea, and that's something that's implemented in yada yada yada. Where is it? There should be a jump to, let's say, Spring domain events. There should be. There it is. Right. So there's a bit of stuff included. There's some APIs, but and it basically lays out the actual problem. So there's a couple of components involved here that are. Let's pull that up. A couple of components here. So we have some kind of event serializer where we sort of have to temporarily store that event in that transaction log. The default implementation just like does a Jackson write event. There is a JPA integration with that, so that the event or the basically there's some kind of JPA-based wrapper that then stores the event because we're sort of assuming JPA. You can of course. I didn't want to pull in anything Spring Data here because that's like a bit more low level. You can, of course, imagine a JDBC, plain JDBC-based implementation of that as well. There's a Spring Boot starter. And actually, in the monolith example that I've just shown you, that is already in place. So it's kind of like put in there. It basically just exchanges the Spring application event multicaster. I'm pretty sure that no one of you has ever had to do that, like manually exchange that multicaster implementation, because it's just a framework internal hook. And there's a bit of stuff that's very, let's say, implemented in a very optimistic way. So there's a lot of knowledge about the Spring Framework internals. I'm like invoking methods via reflection, and I'm currently working with Gierke on getting some improvements into Spring Framework 5.2 to make this, let's say, less brittle. Right? It's not something I'd recommend to use in production, but it will be based on Spring Framework 5.2. I guess we're quite a bit ahead there. I'm not sure it's going to ever make it into Spring Framework itself. We'll see that, but yeah, that's sort of it. So the fundamental differences between our monolith and, or what did we actually gain in the first place? That's more of a, the first thing is more of a design thing. It's basically where code lives. I mean, that's kind of like a very fundamental and very, very ubiquitous task to actually, or to something to think about. Where does some code live or some functionality live? The first thing is it's the domain logic has moved to the aggregate. So the aggregate decides which events get published. It's basically governing the state transitions, when are state transitions allowed. We just had a very passionate discussion in the break here about like, oh, now I have this dependency from my domain class to the framework, and I'm like, yeah, you can of course completely avoid that. It's that I applaud the intention, and I think it's good to be aware of the fact, and it's a good idea to keep that dependency as thin as possible. But at the same time, if for that dependency you get a lot of benefits, and I'd argue you do in this case, then it might be worth just adding it, because the alternative might be to just like write a lot of technical code which you want to avoid as well, right? So integration of bounded context is implemented using events, meaning that we can avoid component dependencies. And if you think about it, that's actually helping with another issue or another aspect, which is testing these individual bounded contexts. With my former approach, or in the monolithic approach, basically had to have these dependencies to the inventory, to the reward system. And when we were bootstrapping the system, we needed to invoke or to bootstrap all these other systems as well, and that caused the actual issues when we were splitting this up into different systems, because then the dependencies were not Spring Beans anymore that had to be bootstrapped, but actual other systems, which made the entire process slow. In my first talk on Thursday, I'm going to talk about like strategies how to actually make those individual bounded contexts bootstrappable with Spring Boot. So the idea being that if you have like a set of these bounded contexts, that you should be able to just write an integration test, a simple Spring integration test that just bootstraps that part of the system. That's already available for layers, so you can say add data JPA test in boot, and it will just bootstrap the repositories. So it's like horizontally dividing the application. But there's some, again, prototypical code that I've built to actually do that in a vertical way. So you can say, just bootstrap only, let's say, the order system, or let's bootstrap the order system and all the modules it depends on, and the modules they depend on in turn. And that might create quite a tree of modules or like bounded context to be bootstrapped. And the switch to the event-based interaction actually cuts off a lot of these direct dependencies and the need to actually bootstrap other modules as well, right, for tests, which means faster test startup, reduced cycle time, green bars for the win. Right. So there's more benefit to it than just the fact that we've now sort of created this kind of indirection. It often helps cutting up dependencies to other systems. That's what I've just basically told you. And it's sort of inverting the dependencies, but in this case, of course, it's kind of I shaped the problem just to make that point here, right? That we resolve that cyclic dependency. One question that also came up in the break was, what you would do to if you actually wanted to extract parts of the system that might have different scaling characteristics, or the team is one that's working external, or so let's say you have any kind of requirement that makes you think, okay, this is something that we should keep as a separate process. And the question then comes up with how do you actually let these systems communicate? And as I said before, when I usually say events, people often think messaging in the first place. So some kind of messaging. We're going to have a look at the options in a bit. And then I also want to talk about an approach to integrate those systems via REST, and probably in a way that you might not have thought about REST before. So there's a couple of different or additional questions that I want to keep, or want you to keep in mind when we discuss this, which is already like sort of, or that one actually came up before, is what do we actually need to run a single system, right? So what do we, what kind of infrastructure do we need to bootstrap? What do we need to Dockerize, so to say? Yeah? What happens if one of the systems goes down, right? So in a production environment, what does that mean to the functionality of other systems? Again, I'm sort of coming back to the fact that the problem that we've identified before, that if you have a system that's calling another system to do its work, which then might be calling yet another system, then there might be you might have to deal with, okay, some kind of defaults. Okay, I can reach the recommendation system, so I need to just say, okay, then there's no recommendations available, so I just show an empty list or whatnot. So you have to define fallbacks and other things. But what does that look like in this scenario, right? When we've now switched to event-based interaction instead of like direct interaction. Also, what happens if one of the failing systems comes up again? So let's say the inventory goes down and we receive requests to complete orders in the meantime. What happens to those things, and how do they actually get in sync again later on? And slightly related but significantly different, the question, what happens if we add a new system to the system overall, right? So again, coming back to our recommendation system, let's say we decided to build it as a separate system. What kind of events do we see? Can we consume the events that we've seen before, or how does that work? All right. So the first thing, messaging. So the fundamental idea is that you publish the events that your system creates as messages through a message broker. And nowadays, you don't get around to talk about message brokers without talking about Kafka, right? So Kafka has I get to that in a bit as well. It's like the most interesting aspect or difference in that context to other message brokers is that it keeps the messages around forever, right? With things like AMQP or JMS, you just like consume the messages and they're gone. It keeps the messages around forever. The idea is that the catalog would produce an event saying product edit to Kafka, and it would then be consumed by, let's say, another system. Can you imagine why would the order system actually listen for a product edit event? Any idea? Just shout it out.
Well, you could order then a new item. Wouldn't that be the case?
Okay, so the order would have to know about about the line items, and they refer to product, right? So there's some information you actually need to keep in that system. That's actually the thing I was getting after. What you see in these kinds of systems is that there's hardly, or you usually try to avoid like references to data living in other systems. So you keep some kind of copy of that data, only the relevant parts of that information or the parts that are relevant to that bounded context. In other words, let's say our product description in the catalog has a lot of details. It has image data attached. It has supplier information attached, what have you. But for the order, the only thing that's interesting is that, let's say, the summary description, because that's something we're going to need to to display the order, right? Because you don't want to just display, okay, there's product 4711 and you ordered one of them and that's like a 400 euros or something. So there's a bit of information, and the idea is that you'd never really reach out to actually ask for that information, but you'd fundamentally ask for like the products being added and the product description being updated to be notified by that, and then update your local copy. You effectively get some kind of eventual consistency here, right? So because that's just fine here, but that's the way that the order would basically duplicate some information, replicate it, and exactly the stuff that it needs to. It's some kind of domain mapping going on here. So it would complete or publish an order completed event itself. That would then be listened to by the inventory, which then listens for order completed and product added, yada yada yada. I think you get the gist of it, right? So we can integrate that. What I think is a bit weird about that is the following. So we started with the idea that microservices is all about like sort of self-containedness of the system. So we want to have a system that I can bootstrap and that would be able to do something on its own. It would provide value add if you just like invoke some functionality and you get a result. And weren't we told that integration, like microservices, are supposed to have individual databases, or at least database schemas, right? So they're basically controlling, they're governing their own schema. And now you tell me the first thing we do is put some infrastructure in the middle of all of it that everyone actually has to talk to, right? That's kind of weird, I think, and it's actually something that's becoming more, or it's even more of an organizational problem than a technical one, because if you get into the DevOps discussions and the idea of teams running their own the infrastructure that they need for, let's say, their system, then the question comes up like, who's responsible for running that Kafka thing, right? I've seen projects where there's this in Germany we have this term called Kehrwoche. If anyone like from the southern part of Germany is familiar with that, it's literally like if you live in a shared house, like a multi flat house, then somebody has to clean up the hallways, right? And there's this paper thing that you hand from flat to flat every week, and the party that has that thing is responsible to clean up the hallways. And I've seen companies that actually have the same kind of thing for maintaining shared infrastructure. So it's this month, this team takes care of that. This month is the other team. I'm not going to say which customer that is. Yeah. Anyway, it's kind of. I'm not saying this is wrong and this is problematic. I'm just saying it's at odds with our actual goals, right? Of keeping our systems separate and self-contained, and like not like we want to get to this shared nothing architecture kind of thing. And what a more technical consequence of that is that we sort of we sort of rely on that. I mean that piece of software actually being available. I mean that's fine. We sort of rely on that on the network being available. We rely on DNS to be available if we want to like invoke systems on other in other parts of our overall system. So there is some shared technology that we have to rely on. The question is just for that kind of stuff, especially if it becomes the central hub for, let's say, where all of our events live, is that something we really want, right? There could be one system flooding that central broker with events, and that could cause another system just not being able to publish anymore or having trouble to publish in time. The other question is, okay, how long do these messages actually live in the broker, right? How long are other clients actually able to see these events? And this is something that you might then formally decide within the publishing system. However, it's actually implemented in some shared kind of infrastructure. And I'd also raise the question, like, if a shared database table, I mean, how is a shared event adjacent structure different than a shared database table? Conceptually, Not really, right? The only difference is that, let's say, if you have that the individual systems owning their database, then you have the ability to map, right? You can hide. You have one thing that's internal to your system, that's your database tables, and the other thing is that what you publish, right? There's usually some more attention being paid to the stuff that you actively share. Then by accident, you just like written to the database, and you never knew that this other team basically read from the very same database and is now surprised that you've renamed that column, right? So there's some mapping that's fine, right? So you have some indirection here. Still, it's sort of effectively the same thing. What you put there is something you can hardly change. On the other hand, it's definitely technology built for scale. So there was this article about, I think, the New York Times building or revamping their article publication system on Kafka, and they have every version of every article they've written starting from the 1800s in that thing. I wasn't aware Kafka was available back then, but just kidding. They just like scanned these things and put that in there. Put the information in there. Yeah, that's the thing. The fundamental idea is, and that's going to be different in the REST approach, is that we publish events as messages. That's the design decision that we put in place at this point, right? It's not something that's set in stone, and it comes to surprise to some that you can do or you can publish events in a different way. But I'm going to come to that in a second. Key characteristics of different broker technologies. So without going into many details, the fundamental difference with Kafka, and that's why I see it being used in so many places, is that it keeps those messages around forever, and that allows systems to show up and see old messages, and that's something that's not necessarily or easily doable, and also just in a very limited way doable in the alternatives. Because for JMS and AMQP, a system has to at least once register with the broker and say, I'm interested in the messages on topic orders or orders completed or what have you. And in AMQP, for example, that causes the creation of a fan-out exchange. And even if that client system goes down, the events that are arriving in the broker are buffered, and once the system comes up again, published to that client system. With Kafka, you just like register for that partition and topic, and then you have an offset basically where you can define what point you want to read from. That has the fundamental advantage of being able to deploy a new system and see old messages, which is kind of we've had this rewards system or rewards module thing. It's not something I actually made up from thin air. It's actually a customer's project, and they were able to deploy this new feature and run all the orders of the last couple of years through that system. So they deployed a new feature and immediately had customers that had piled up a couple of rewards points. So that was kind of neat to see, right, in their case. Something that's also a neat topic for discussion is coupling, right? Because people tell me that, if I build a message-driven system, then I reduce the coupling between my systems. And that's oftentimes, okay, what does that even mean? We deploy, we just send messages around. Okay, how do the systems agree on the understanding about the semantics on the message? Yeah, it's just JSON. Okay, so what's the fundamental difference between some JSON received via an HTTP call and some JSON received via a message broker? Surprise, there is none, really. Even worse, there's no concept in messaging or in that approach that sort of allows to add a new serialization format easily. So the format that a client can see things in is fundamentally defined at the point in time when something gets published. That's fundamentally different in the REST world. I get to that in a second. But the only way to basically shape the messages is by listening to them and then republishing them in a different format into a slightly different topic, which is perfectly doable. There's even like Kafka has like the API to the case streams and whatnot to actually do that in a very efficient way. However, it's something that you have to do manually, right? So you have to sort of take the data, crunch it, and change it, and then republish it actually. So you're duplicating the data that's actually stored in that in that broker. And something that a lot of people also miss is that even with just with that simple broker, okay, I want to publish that event, you're actually running into transactionality is something that's playing into this. So you'd actually need like something like XA transaction or a two-phase commit to publish the messages, assuming you have a transactional store, right? Because you want to fundamentally tie the message publication to a transaction commit as well. And that means you have to, let's say, coordinate the publication with the transaction somehow. And then the question comes up either you publish the message before, and then on a rollback you sort of have to unpublish the message, or you wait for the commit first, and then what happens if you can't reach the broker at that point in time, right? So it's kind of like yet another technical issue to solve here, right? It's not something we're getting for free. Yeah. All right. So what would we actually do if we change that to work with REST instead? The fundamental difference here is that that's something that the REST world is that's a very fundamental concept to the idea of REST, is that the important bit is the application state, right? When you talk about REST in general, you say, okay, statelessness is a requirement for a REST API, which means you don't want to have no session state, and the recommendation usually is turn session state into application state. In other words, a shopping cart or something is not something that's just like somewhere in a session, but it's an actual application. It's a domain thing, right? So we have a shopping cart. It's actually persisted to the database. It's turned, so it's application state. It's not just some arbitrary thing. And guess what? You can do the same with events. So you can just argue that the publication of an event is just an entry, another entry in a database table, for example, right? And then you put some API on top of it that basically allows you to read those entries. And again, surprise, surprise, there's already formats that have been around for ages, if not decades, to actually let clients consume feeds of events, right? Have you heard of Atom, for example, or RSS, the ugly stepchild, I guess. But that's the kind of idea. So you could go ahead and just store the events in the very same database. That basically means that you build client systems that then go ahead and, of course, poll those APIs. That's the usual reaction is, seriously, you want to poll the send HTTP requests around for every. What about if you have a gazillion of other systems? Not sure if I tell you a secret here, but the connection between a Kafka client and the Kafka broker is an HTTP call. It's basically using long polling, so it's keeping the connection open. So there's no way you can publish the events without actually keeping the connections open anyway. The other thing is HTTP has quite sophisticated means to optimize for that. So you can use conditional GET requests. Basically, give me, let's say, we ask for the list of events and we get let's say 10 back, and then we of course remember the some kind of offset or the point in time that the last event was published, and then the next request we ask for all the events after that, and we do, let's say, add some if non-match headers, for example. That's something we could also use on the collection. So basically just give me events if there are any new ones. And we could also be intelligent about our polling strategy, because we could realize that, oh, we've now, like for 1 minute, asked every 5 seconds for new events. And we realized we didn't actually get any. So maybe we just like turn down our scheduling frequency or request frequency, and as soon as we feel okay, there's more events coming in, then we just like increase that again. And as I said, because you're probably going to have some kind of web API for anything external anyway, it's kind of neat to just be able to use the same paradigm to implement that kind of stuff. So you just go ahead and do the same kind of polling. Oftentimes, if you what plays into this, oftentimes you have to accept, not oftentimes, but you have to accept eventual consistency between the systems anyway. And very often it's then not, it doesn't make a huge difference whether it's, let's say, a couple of 100 milliseconds or a couple of milliseconds to see the Kafka message or the AMQP message, or let's say if it's a couple of milliseconds to seconds to see the updated state in the inventory, right? I often get into these discussions about like, oh yeah, but we have to know about the precise number of, in this case, TVs in our state at any given point in time. That might be the case, but if you're building a web application, if you think about that, you don't even have to go into the multiple systems case. If you build a web application, you by definition have a multiple systems case, the client and the server. And by the moment that, let's say, if I go to Amazon and assuming we had detailed information about the stock on a product web page. So it would literally say there's 5 TVs, there's 4 TVs, there's 3 TVs. The moment I have this on my screen, it's outdated information, right? Because like a millisecond after that, it could have changed. So we sort of have to assume that this is not, what we see is basically the thing, the state the system was in when I send out the request. But it's not the state. Okay, 2 seconds later, it could be just like an arbitrary, or that value could have changed. In most cases, for these kinds of scenario, there's like some kind of traffic light system where you say, okay, green, there's enough on stock. Yellow, oh my gosh, they're becoming just a few, and red is we're out of stock. I've heard about companies that that try to create incentives for people to buy stuff by just continuously putting on the website that, oh, there's only a few of them, a few of these TVs available still. So that's kind of like business opportunities here. So the idea is fundamentally that we have HTTP resources to consume events, which has a lot of fundamental consequences, right? So before we go into those, what I usually suggest is, okay, we have a resource that is, of course, has to be filterable by event type. That's pretty easy to build because, I mean, just like by type, yada yada, parameter, there's HTTP means for that. You can use pagination and caching to optimize the interaction. There's also the ability to, or you can actually change the format you want to publish these events in after they have been published, right? Because the format they get published in gets decided when someone is actually reading the events. There's this thing called content negotiation, which is a proven mechanism, or has been a proven mechanism in HTTP for quite a while, so that you could later on add support for new data formats, or you could even decide to version that API if you wanted, or just like return the orders in some format or then in another format. There's a couple of different things here. I'm not saying again you can't build this with the other approach. I'm just saying for that kind of stuff, there's already mechanisms in place in one scenario, and you have to completely build that yourself in the other scenario. Something you have to completely build yourself is that kind of polling thing and that the smarts that you want to put in there, right? It might be the an opportunity to actually to share some code, like to put that into a library, but essentially it's definitely something you have to build yourself. So you poll the system. So the polling is a pretty fundamental thing because that sort of shifts the responsibility of the consistency gap to the consumer. What do I mean with that? With the message broker approach, you basically register with the message broker, say I'm interested in these kinds of events, and then you get flooded with events, or potentially flooded by events. With the polling approach, the system the reading or the listening system very much controls the amounts of message. When does it see which messages? Because it can just like pause polling completely. Let's say you have you realize there's quite a bit of load on that system, and you'd have to sort of handle that or make that a bigger priority. You could just like tone down the polling frequency, or just like stop polling completely. That creates a bigger consistency gap, fine, but the client is in charge here. That's what I have down here. The other thing that's in place, I'm not sure, does it come on? I think that's in these slides. The biggest implication, or I think that this approach has, is that I don't need any other infrastructure to like both like run the system and serve events, and I don't need any other infrastructure. If I want to test the updating logic, then I can of course write integration tests, and then I have to mock the server by some means. But usually that kind of functionality is very technical and can be tested once, and then there's means in code we can have a look at that in a second, where you have API where you just trigger the update logic by invoking a method. So you don't actually have to have another system that you're able to poll, because that's like technical infrastructure code that you can test separately. The other very important aspect here is that, and that's kind of, I think that's maybe even more important, is that the publishing the events. Would you guys mind? Sorry, thanks. Is that publishing an event is just inserting a line into a database table, right, or a row, basically. It doesn't need any kind of sophisticated transaction semantics. So it's just consistent with what you've done on the transactional system in the first place. It's either done or it's not done, right? It just takes part in the local transaction. And it's just like pretty easy to implement. The publishing system is in charge of how long these events are actually published. Like, what does that mean? Like, what kind of events can a client see? I can even go ahead and implement some strategies for some clients. I can employ security strategies and what events can be seen, what details can be seen by requiring the polling clients to authenticate with the other system. That's something that's slightly harder to do with message-based systems as well. And what I think is also kind of important is that the events stay part of the publishing system. So there's no one big kind of bucket that everyone throws their events into, and that's basically just like a big giant sea of events. It's still, of course, a downside I might have to add actually is that if you want to aggregate different kinds of events for reporting purposes, then having that canonical place where you can go to actually read all these things is of course an advantage, and that's something that you'd have to build in this scenario here in a way that you just like listen for all the other events and then build a piece of software that's aggregating all that stuff again. So different trade-offs. definitely something, if you're building a trading application that needs to process a couple of thousand or millions of messages per second, then that approach might fail completely, right? Because, I mean, you probably can build something, but I definitely, it's something where you can live with a slightly bigger consistency window here. All right. Let me just, before we go to the summary, let me show you a bit of the code that's actually in place here. So for the messaging side of things, I should have shown you this earlier, but and what we've also discussed in the what we had in this discussion in the break was, okay, how if we have our own, if we have our domain logic, how do we actually avoid messaging? That probably should be it. Wait, catalog, that's the wrong one. We want to avoid that, like, infrastructure is leaking into the domain, and there is that's messaging. That's weird. Order application, product info. I'm not sure I messed things up, but what do I have here? The order completed event. Where is that living? Oh yeah. Here's my order. That order has the add product complete. Who's calling that? I just need order controller. Okay, so there's no service involved here. Fine. We just call that order complete method here. That's what we had before. That's publishing the event. So I'm still using, although we're building a distributed system, for the structure internally, I'm still using the very same eventing mechanism. That's something that I think is quite a neat idea. So people often think that you have to start building systems around a single bounded context. So microservices means you have a single bounded context, and that's going to be the deployment unit. I don't think there's anything terribly wrong if you decide to keep a couple of bounded contexts in the very same deployment unit. For example, this comes in quite handy if you're not sure about the boundaries in the first place, and you have the feeling that we don't know enough about the domain to actually really decide where to draw the lines, and we might run into the situation that we have to reshape those bounded contexts, right? And then keep those 3 or 4 together, interact using events, find some means. Hint, hint, the talk on Thursday morning. Find some means to keep the structure around in this more monolithic kind of thing, and then extract later on when you actually have the need, or you're confident enough to say, okay, this is now where I want to split things apart. The way the externalization of events usually happens is through an external component. So you have your domain code, like your aggregates, your repositories, your services, have that only with very thin dependencies to frameworks. If that really pays off, I definitely never go ahead and put some Kafka reference or something like that in, like the integration technology specific code into my domain. But what you can then do is, in this case here, is a Spring component. It's an event listener. It listens to the event. So that kind of event listening is internal. It's synchronous. And it basically then interacts with, in this case, some component from Spring Kafka that says, here's the, please publish this message to the orders topic. So we have this external thing, and that then sort of externalizes the event of to third-party systems. That gets you to a nice decoupling of, okay, there could be like 10, 15, 20 events internally, but to third parties we only expose like 3 or 4 of them, and you can very selectively do this here, right? And on the listening side of things, that looks something like this: Kafka integration. It's again Spring Kafka, and it is we're listening to the products. Where is the other thing? To the orders thing here, and again, something that I found, so what does this thing do? It's a component. It registers with Kafka. It basically says, whenever listen to the orders topic, that handle it in a transactional way, and that order completed event is down here. It's just an interface. I'll get to that in a second. And then for every message we get just that method invoked. We stream over the line items, we log some information, and then we trigger the update of the inventory item. And because of the fact that this is transactional, this is just like becoming one transaction, and it just works for the message or it doesn't. So it gets acknowledged the appropriate way. Something that is in play here, and that's actually also, again, a Spring Data feature, is sort of getting into the realm of like, how strongly do I bind bind my client to the data structure of the message that the publisher has chosen. And we are used to, in the Java world, we're pretty used to, and I hardly find people thinking about it in a different way, but we're used to describe the payloads in classes and class hierarchies, like let's say Jackson, what have you, right? So yes, when you get some JSON structure, what do? You create a class that has a property for every field, and for every complex field, that property is of another complex type. So we're baking a lot of structural information into our own code, because if we're now, let's say the order class, it has a line item. It has a line item here, and if I just call line item instance get product number, if we marshal that using Jackson, that we'd have some code in our client code that says order get line items for each, and then get product information. So that's kind of that's kind of coupling the structure, the nesting structure of the payload to our own code, right? And it's something people hardly get ever off from. The thing that I've shown you here is that there is a different approach that's been available in Spring Data for quite a while, which is the idea that you instead, I mean, if in case you don't know about Spring Data, there's like you can create repositories by just defining interfaces, putting methods in it, and we do the right thing TM. The idea here is that you just declare accessor methods, getter methods, and by default, let's say this thing here, just the line item was bound to a JSON document. The call to get product number would return you the value that's in the product number field in the JSON. The call to quantity would return you the value that's in the quantity field, right? And if you wanna like peek into the object deeper, you can define the JSON path expression that basically pulls out a particular value in here. And the cool thing about this is that it doesn't, I mean, that's kind of flexible, and it's only kind of mapping the parts of the document that you're interested in, which of course also works with Jackson. However, there is a neat feature that I think comes in very handy, is that you can actually define multiple of these expressions, and the first one that actually finds a value is used. So it would actually look for order ID, as the order property, nested document ID in the first place, and if there's no value there, it would just like look for the ID value on the very top level. That's kind of a neat feature to like sort of adhere to changes in the document structure, right? So if someone had changed like the place that you find a particular property in, you can have, I mean, this is kind of a JSON path is like just like XPath, a language where you can define predicates and whatnot to filter the properties that you're interested in. The biggest feature, however, is that that switch between these two two expressions in Jackson, or I'm not trying to blame Jackson here, but in a class-based approach, in a plain class-based approach, that would mean that the method moves to a different object, right, or to let's say on a different level, and that would mean you'd have to touch all the client code that's actually making use of that, which is not the case here. So you just define what you'd actually like to see, and then you just get this thing bound into into the message broker here. So there's some Spring Kafka integration that with boot then realizing, oh, there's Spring Kafka and there's Spring Data, and then it just like activates that functionality for you. So it's kind of slick and neat to have that. Again, like the fundamental idea that we want to tie our code as little as possible to other code. Is here anything else? Oh, I wanted to show you the REST side of things. That involves a bit more messaging. Nope. Oh, SOS REST. There it is. Inventory. There should be the integration is a bit more integration. That's the integration thing. Catalog integration. Yeah. Okay. There we go. You see a bit more code, fine, but what it actually does, it's an add scheduled method. We say every 5 seconds. Oh yeah, so there's some hypermedia-based resource discovery going on. So we have a so-called remote resource that is discovered using a feature in Spring Cloud. So we're actually using it. So I'm not using a Eureka or anything like that. I'm just like baking in the information about where the other system, like the catalog, lives in that very system. I just put it in code here, so you could replace that with something like Eureka. So this is the service discovery part of it, and what we then do is we define a so-called traversal, which means that we issue a request to that very system, so the root resource. We get back a list of links, and we follow the events link. That's the way we find out where we can actually ask for the events. So the agreement that you basically do on the macro architecture level is every system exposes on the root resource a link that's named events, and that sort of works in a certain way. We can expose that to the application context as a so-called remote resource, and that will then expose a link, and we basically just check whether this is present or not. Because that infrastructure, it discovers the link in the first place, and then it regularly does head requests to verify that the other resource is still there. And if it's not there, it's triggering a rediscovery. That means that the system can go down and can come up, and it would automatically be available. Because in other words, that code here is only triggered if the other system, the event publishing system, is actually available, right? It could just be unavailable for crash reasons, so it could just, or the network partition kicking in or anything like that. But it could also mean that it wants to change anything about its API. It wants to change the URI that the events can be found under. Fine, yeah. It would just like automatically back off in this case. And it's basically, we're looking up an integration, find unique integration. We ask for the product edit events, and we basically we just add an additional time or an additional parameter that basically says, okay, if we have accessed events before, then we basically remember the date of the event that we've actually got the last event that we got, and then we just ask for the newer ones. Then we ask for HAL, and if that's the case, we just use the initialized inventory method, and that basically goes ahead and triggers, for every resource that we got back, it just adds the catalog. In this case, what is it? Publication date, ISO date, time, and then remembers the last date that we've sort of got for the event, right? And it's the inventory. Where is that thing here? There it is. Right. Okay, slightly more complicated, but kind of neat to work with. What's also kind of funny is a couple of customers that basically use that kind of event-based integration or HTTP event-based integration is that I've seen a couple of them using Atom instead of HAL. That actually comes with a nice side effect that you can open up a feed reader and put that to the URI, or point that to the URI, and then basically debug your production system with a feed reader. Google Reader, may you rest in peace. It's been a while, but still, I'm sad. We had that slide deck, did we? Yep. Right. So to summarize, a couple of recommendations or high-level recommendations I want to give, or not recommendations, heuristics, because the important point is not that I basically tell you what to do. The important point is that you take a couple of questions with you when you just like walk out of this room to ask yourself and basically impose on your own projects. I generally recommend to build rather monolithic systems in favor of, or no, over, that's probably the right way of phrasing it, over like premature microservicization. Is that something? The reason, especially in cases where you're not sure about the domain, if you still have to learn a lot about the domain, if you're not sure about the boundaries of the bounded context, keep systems like more monolithic. But at the same time, I'd never start a project that actually consists of a single system only, because then you sort of just postpone all the decisions that you have to do, like about how do we actually integrate, how do we monitor the interaction between the systems, to a point in time in the project where you might actually not want to deal with these kinds of things or these kinds of decisions anymore. So building 2 or 3 or 4 or 5 systems, depending on the overall size of it, each containing 1 or 2 or 3 bounded contexts, sounds like a reasonable startup to me, right? Event-based interaction. So I see a lot of talks these days that tell me that HTTP or REST is dead and you only need GraphQL. I see a lot of talks that tell me that REST is dead because it means synchronous remote system invocation, which is not the case necessarily, but that's kind of a fundamental misunderstanding of or tying together the kind of interaction, the architectural kind of interaction between the systems, and using HTTP for that, right? So the problem is in those direct method invocations or that direct API invocations. Prefer to use to integrate via events, right? And if that feels unnatural at that place, then it might be an indication that is actually not a bounded context boundary that you're basically kicking over. The fundamental or the fundamental difference between or one fundamental difference between the REST and the messaging approach is that in the messaging world you sort of build a distributed system but not a decentralized system, because everything is integrating over that single node. With the REST-based system, you're kind of building something that's closer to the analogy of the internet in the first place, where you just had new systems coming up, and as long as someone or something is pointing to it, then it can actually be part of that overall system, right? The fastest or the most efficient way to do remote interaction is to not do it. That's sort of like the analogy to Martin Fowler's first rule of distributed objects: don't do it. We're not necessarily talking about distributed objects, but there's no faster way a better way to avoid coupling, to do no coupling at all, right? So just don't call the other system. And if you have to, then do it definitely asynchronously and outside the user request. That's the thing. Asynchronous, in general, asynchronous alone is not enough. Because if there's still the user request waiting for that response, then that's kind of just like broken, right? So try to be able to answer user requests from your local state. And that thing that we just briefly touched, the idea of replicating data into your own data store or parts of domain data into your own data store is kind of is a very good approach for that. So if that allows you to answer user request without reaching out to another system, then that sounds like a good idea. And to quote Stefan in there, I just realized I can hardly build a talk without quoting Stefan Tilkov these days. That's kind of interesting. But yeah, it's kind of like the fundamental idea that there is a very many good parts in building a monolith, right? So a monolith is like, I sort of hate the comparison, but someone once told me that a monolith is like a stereotypical like computer programmer, right? He's like wants to be on his own, not talk to anyone. Not sure I agree with that, but that attitude towards interaction with other systems is kind of neat, and there's no reason why you necessarily have to give that up if you just build more than one system. That's kind of like a fundamental misassumption, I think. Right. Okay, I mentioned that already. So there's a huge difference in system characteristics between these different integration approaches. I try to graphically get the point across that I want to make with this. Is that on the y-axis we have the number of systems that we have to interact with to actually give a reasonable answer to a user request, and on the other axis, on the x-axis, we have the amount of systems that make up our entire system. And with a monolith, you're of course in the lower left corner, right? So you have a single system and you don't necessarily talk to other systems in your system. There might be third-party integrations like a payment provider, what have you, but like within your own system, there's just like one. And things get really tricky if you have very many systems and you have and you need to talk to a lot of them when you actually to serve a user request. That system of systems approach, let's say, stay more monolithic, integrate via events, state synchronization outside user requests, makes your system coming down to sort of this position where you have a couple of systems that your overall system is made up of, but you don't necessarily have to talk to them synchronously. I go into much more detail about this monolithic application with Spring Boot thing on Thursday morning. And there is this REST talk where it's about like API design in the context of microservices at noon the same day. I think it's this room again. All right, with that, please make sure you rate the session. Even more than the actual rate, I'm interested in feedback and comments, stuff you liked, stuff you didn't like, to just improve that for further iterations. And with that, thank you very much. I'm around until Thursday, even if you're not attending the talk. I'm the short one with the head. Come to the Pivotal booth, say hi, talk stuff with me, that's fine. See you around and have fun at the conference.